So today let's take a look at some trends in the periodic table. A couple of things. Let's take a look at this one. It's example number one. It says magnesium, calcium, sulfur, and phosphorus. And I want to put them from largest radii to smallest, and then largest ionization energy to smallest also. Couple of things. This is where you have to know these trends. Z effective increases across a period. So it increases across a period and decreases down a group. So you have to know that. Couple of things. The larger the Z effective, the smaller the radii. So a Z effective increases, radii decreases. So those are trends that you have to know. Couple of things also, as Z effective increases, ionization energy increases. So we have to kind of know those trends. Z effective is the ability to pull in electrons. It pulls it in tighter, makes it smaller, also more difficult to remove the electron. So taking a look at this one, what you want to do is compare them within the same group in the same period to kind of get some ideas. So in this case, I got magnesium, calcium, sulfur, phosphorus. Magnesium, phosphorus, and sulfur are period 3, and then calcium is going to be period 4, but it's going to be in group 2, same group as calcium. So the way I look at it, if I want to compare calcium and phosphorus, well, calcium is going to be larger because what happens is Z effective decreases down a group. So calcium is greater than magnesium. Now, as I go across a period, Z effective increases, which means now my atomic radii is going to decrease. So basically, magnesium is going to be greater than phosphorus and sulfur. So magnesium is greater than phosphorus and then greater than sulfur. So again, a couple of things. Z effective increase across the period, which makes the radii smaller. So again, magnesium is going to be the largest then phosphorus, and then sulfur. And then down a group, Z effective decreases, which means the radii is going to get bigger. So calcium is below phosphorus, which is larger. So calcium is larger than phosphorus. Now, the other one is ionization energy. Ionization energy, again, Z effective increases across a period, which means ionization energy is going to increase. Z effective decreases down a group, which means that ionization energy is going to decrease. It's kind of like the opposite trend for radii. So again, I'm going to compare calcium and magnesium. Well, calcium is below it in the periodic table, which means now its ionization energy is less. So basically, magnesium has a greater ionization energy than calcium. So again, this is compared within the same group and in the same period. Now, as I go across period number 3 now, ionization is going to increase. So basically, sulfur has a greater ionization energy than phosphorus, which is going to be greater than magnesium. So basically now, sulfur greater than phosphorus, greater than magnesium. So again, when you're looking at this, compare within the same period, compare within the same group, and always remember, everything's based on the Z effective. As it increases across the group, radii decreases, ionization energy increases, decreases across the period, I'm sorry. Down a group, Z effective decreases, radii gets larger, and ionization energy is going to decrease. So in this case now, again, we're going to look at smallest radii to largest. Now these are ions. Now when I have ions now, what I want to do is compare the number of protons and electrons. So first thing I want to do for fluorine ion, fluoride, magnesium, sodium, and then the oxide, I'm going to write down a number of protons and electrons. So fluorine is going to have 9 protons and then 10 electrons. It has a -1 charge, so it's 10 electrons. Magnesium is going to have 12 protons, 10 electrons. Sodium, 11 protons, 10 electrons. And then oxygen, 8 protons, 10 electrons. So whenever you're doing these, when you're comparing ions, compare either electrons or protons. Now, all my electrons are the same. So those are going to be the same throughout. So then I'm going to look at the number of protons. So basically, if the electrons are the same, the more protons I have, the stronger the effective nuclear charge is going to be. So basically, in this case, more protons, Z effective is going to increase. And again, the number of electrons stays the same, so I know this is going to be the case. So basically, remember, the higher the Z effective, radii decreases. So again, everything is really based on Z effective. So in this case right here now, magnesium has the most protons, so that's going to be the smallest. So magnesium is going to be the smallest. It has 12 protons. It's going to pull those electrons in even tighter than something like oxygen. Oxygen only has 8 protons, so the electrons are not going to be tightly pulled in. So it's going to be a little bit larger oxygen than magnesium. So magnesium, and then sodium, fluorine, and then oxygen. So basically now, oxygen is the smallest, is going to be the largest now. It only has 8 protons. Those 10 electrons are not going to feel to pull as much. And then magnesium, in that case, is going to be the smallest. It's going to pull in the electrons the most.